Okay, in this video, we are going to go into more depth with leading coefficient and degree, and then I'll discuss how you can use that to find the end behavior of a polynomial. So in this first example, I'm going to first write this in descending order. So I'm just reorganizing or reordering the term so that it goes from the highest exponent of x down to the lowest. And now I can identify what the degree is. The degree is the highest exponent of x, so that would be 5. And my leading coefficient, I'll abbreviate it LC, is -6. Now for the second example, the 3x minus 7 squared means 3x minus 7 times 3x minus 7. Now, in order to identify the leading coefficient and the degree, I need to imagine what that would look like if I multiplied that all out and expanded it, and then put it in descending order. So some people can do this without actually multiplying it out, but if you can't do that, then actually go ahead through the process of multiplying that out, and then you can organize it in descending order. But for those of you who can visualize it, if you look at the leading term of each factor and I multiply those together, that's going to give me the leading term of the entire polynomial. So if I take x squared times 3x, that's going to give me 9x to the 4th. So this would be my leading term if I multiplied all of that out. So I can now identify what my degree is. My degree would be 4. And my leading coefficient, abbreviated LC, would be 9. Okay, now going on to end behavior of a polynomial. The end behavior of a polynomial is when you look at the graph of a polynomial and you look to see where those arrows are headed. So if I see an arrow that's pointed up and to the right, that means my polynomial is going to go to the right and up forever. So that tells me what the end behavior is on the right side of the polynomial. Now, there's some notation that we use for this. It's called arrow notation. And what we would do is we would say, as x approaches positive infinity, meaning as x goes, if I look at the graph and go all the way out to the right, what happens to my y value? Does the arrow go up or does it go down? So I would indicate that by stating, I'll put a question mark here, but I would indicate that by saying it goes to positive infinity or it goes to negative infinity. And then I would do the same thing for the left side of the graph. I would say, as x goes to negative infinity, where does y go? Does it go to positive infinity or negative infinity? Does it go up or does it go down? So the way that we can identify where those arrows are placed would be by our leading coefficient and our degree. And we have 4 situations for that. So if you imagine that this is my y and my x-axis, if my degree is even and my leading coefficient is positive, then my arrows, when I draw my polynomial, is going to be in the first quadrant and in the second quadrant. Now this arrow here in the first quadrant tells me I'm going to go to the right and up forever. So when I write down my arrow notation, I would say, as x goes to positive infinity, y is going to positive infinity because it's going up. Now for this arrow that's in the second quadrant, this arrow tells me as I go to the left forever, meaning to negative infinity for x, I'm still going up forever. So I would write that as x goes to negative infinity, y goes to positive infinity. Now, the leading coefficient and the degree only tells me the end behavior of the graph. If I were to imagine what goes on in between those arrows, I don't know. It could come down and look like a W, like a quartic. It could come down and look like a quadratic. What goes on in between those arrows is going to be determined by the zeros of the polynomial and something called multiplicities, which we're going to get into in the next section. So keep that in the back of your head. So the leading coefficient and the degree only tells us about the arrow placement on our graph. Okay, if the degree is odd and my leading coefficient is positive, that means my arrows are going to look like this. So that means if I look at this arrow here in the first quadrant, that means as x goes to positive infinity, y is going up to positive infinity. And as x goes to negative infinity, y is going to go down to negative infinity. So I would write that in my arrow notation like this. So as x goes to positive infinity, y goes to positive infinity, and as x goes to negative infinity, y goes to negative infinity. Now, if the leading coefficient is negative, then we have this situation. So if we have the leading coefficient is negative and it's an even degree, and I didn't really say what I meant by an even degree, so let me clarify to make sure that you understand. What I mean by an even degree would be if the degree is 2, 4, 6, 8, and what I mean by an odd degree would be if it's like 1, 3, 5, 7, etc. Okay, so in this scenario, the leading coefficient would be negative and my degree would be even. So my arrows would be in the third and the fourth quadrant. Well, this tells me that as my x goes to positive infinity, my y would go to negative infinity. And as x goes to negative infinity, y goes to positive infinity. So I would write it down using my arrow notation like this. And that would be my arrow notation for a polynomial with the leading coefficient that's negative and an even degree. Last scenario. If my leading coefficient is negative and I have an odd degree, my arrows are going to be in the second and the fourth quadrant, which tells me this arrow is going to go to the right and down forever. And this arrow here in the second quadrant is going to go to the left and up forever. So my arrow notation would look like this. As x goes to positive infinity, y goes to negative infinity. That would be this one here in the fourth quadrant. And then as x goes to negative infinity, y goes up, so it would be to positive infinity. So keep in mind that this tells us about where we place our arrows when we're drawing this on a graph. And then what happens in between is determined by our zeros and something called a multiplicity. Okay, so let's practice this now. So in this example, it says determine the end behavior of the functions. Well, this has an even degree and a positive leading coefficient. So that means as x goes to positive infinity, y is going to go to positive infinity. And as x goes to negative infinity, y is going to go to positive infinity. So my arrows are going to be both facing up. For this example here, if I were to actually multiply this out, I would get a leading term that was 3x to the fifth. So that means I have a positive leading coefficient with an odd degree. So that means my arrows are going to be in the third and in the first quadrant. So I would say as x goes to positive infinity, y goes to positive infinity. And as x goes to, as x goes to negative infinity, y goes to negative infinity. Okay, in the next example, we're finding the end behavior, but then we're going to use a table to verify it. We want to see what the y values are actually approaching what those actual values are so we can make sure that they're headed in the right direction that we think they're going to be headed in. So if I were to multiply this out, I have an x, and then I have a negative x. That would give me a leading term of negative x to the third. So I would have a leading coefficient that's negative, and I would have an odd degree, which means if I were to look at where my arrows are placed, that means I would have arrows that are in the second quadrant and in the fourth quadrant. So that means as x goes to positive infinity, y would go to negative infinity. And as x goes to negative infinity, y would go to positive infinity. So there's our end behavior, but then we can use the table to verify it. So what we're going to do is we're going to plug in negative 10 into this function. So I'm going to take negative 10 minus 5 and multiply that by negative 10 plus 2, and then multiply that by 3 minus a negative 10. When I do that, I get the number 1560. Then I plug in 0. When I plug in 0, I get negative 30. And when I plug in 10, I get negative 420. So how can we use this to verify the direction of my arrows? So this is telling me as x comes out in the negative direction, as x goes to negative infinity, my y value should be coming to positive infinity. And let's check that. And we said that here. As x goes to negative infinity, y should go to positive infinity. So this number is big and it's positive, so it's heading up. Now if I look at this positive 10 down here, as x goes to positive infinity, as x is getting bigger, look what's happening to y. Y is getting smaller, so y is heading towards negative infinity, which is what we said here. So we're just verifying with our y values if it's headed in the right direction that we think it should be heading in.